We're going to start this puppy up. Clear, prop.
And welcome back to Building the Affordaplane. We're about to get started on the stick and kind of finish up the control system. But before we start, I wanted to answer a question that was left over from last week's build. A number of people wrote in and questioned whether the bearings we made out of aluminum for our torque tube were adequate, were strong enough, robust enough, could they do the job, were they safe, and all of that. And that is a great question. Glad people are asking, and they should wonder about all aspects of the build. However, we did get a few comments that were out of line, out of place. A few actually said that it was dangerous, inadequate, they are not going to use it and other people shouldn't. Those comments, of course, I removed because they're wrong, misleading. Nothing wrong with asking a question, but let's not put out bad information out there. Let me tell you why, so that you can feel good about the type of components we use. In the case of that aluminum bearing that we use for the torque tube, it is used on aircraft kits all over the world. Now, I'm not an engineer, so don't take my word for it. Let's look at the facts, the information, what's out there. Now, I have built a number of kits, so I'm familiar with the type of devices and components and materials that are used. These are airplanes designed by aeronautical engineers. They design airplanes for a living. And one in particular, the Zenith 701, uses these bearings throughout the plane. Let's look at one for example. In this one here, this is the bearing opening for the stick, the torque tube for the stick. Now the stick is made out of steel, however, if you notice, the bearing is 1/4 inch aluminum small plates that are attached to a very thin bulkhead. That is the bearing for the stick. The 701, the Zenith 701, this aircraft that this is used on, there are literally multiple thousands of these flying throughout the world for the last 25 years. And this is just one example of using this type of bearing. Here's another example. Take a look at this one. This is the brake and rudder pedal shaft at the very end that the steel shaft pivots on. The thickness of that is even less than what we're using on the Affordaplane, and there is quite a bit of force and torque at that point. So to sum it up, if we can look to other aircraft designed by engineers that have lots of them flying and none of them failing, we should keep in mind that there's a couple of issues when it comes to this. One is, how much does it rotate? In our case, we don't really rotate more than 45 degrees one way or the other with the torque tube when we handle the stick, and the forces are very minimal compared to the thickness of the bearing material where the two pieces touch. And that's why aluminum or steel and aluminum is very adequate, very strong, does the job very nicely. Could you put in a more complicated, sophisticated bearing instead of what we're using? Of course you could. The problem is that it's not inexpensive, easy to build, lightweight, and effective for the job it's doing. So obviously you can use whatever you want, but it is incorrect to say that that bearing is either dangerous, inadequate, shouldn't be used, etc. I would like to think that we have some fact-based information, and of course if you see something that's wrong, be sure to ask. And of course join us on Patreon, where we get a little deeper into all sorts of subjects regarding the building of the Affordaplane. So enough of this, but it was good that some of you asked. Let's get back to building. We are going to prepare for the pivot point for our stick. Now this is going to be built around one of these stainless steel U-brackets, which, if you haven't forgotten, got from the Affordaplane store.com. And it will mount approximately here and be able to rotate. So we need to put a bolt right through here. The plans call for 1/2 inch above the bottom and 1 inch from the edge. I've actually added 1/8 of an inch to this inch because, do not forget, there's a bolt that goes through here with a stack of washers, which are 1/2 inch in diameter. So you come a little bit close with the 1 inch. So the extra 1/8 of an inch inward just gives me a little additional clearance. So I've marked this very precisely on both sides, this side and the back. I will punch and drill this, and we're going to open it up to 1/4 inch for an AN4 bolt that will go through here and allow us to rotate. And we'll get some washers in here, and then this will definitely use a castle nut because this is a rotating area. We don't want to tighten down on it. I've added a number of washers to move the U-clamp out a bit. So our stick is basically 19 inches. And if we go with the original design, it's straight. We'll look at a curved version in a moment and see what that brings us. Basically, 5 inches below the pivot point with the stick, because remember, this now is going to match up with our aileron tube horn down here with a bunch of threaded rod ends and a threaded rod. So 5 inches below. And then 4 inches above will be our aileron control rod, which will go back, not aileron, sorry, elevator control rod, which 4 inches above the pivot point will connect here and go backwards. And then the rest is for gripping. Notice that this additional area allows a little more forward leaning, as opposed to if it was closer, we'd have less of an angle. So we grew the number of degrees of angle by moving this out. So we have some adjustment play here to play with if we need it, as we find out. Now, one of the issues of the straight stick was that as you go forward, you hit the support that we're going to build later here. It'll run into that. So an updated version of the stick is to put a gentle bend in it and move it back 1 inch or so. And that might look something like this. This is kind of a mock-up. Again, 5 inches below, 4 inches above, we have our connection. But note that with this curve going backwards, and maybe the camera's not at a good angle to see that, but we're offset 1 inch. And as we go forward, we get more room, so we can get more of an angle before this runs into our forward support tube here. So we do have some ability to adjust this forward support. We'll look at that later when we install that. But a lot of this can be adjusted through angles, because we can make this any number of ways, as long as we keep, again, the 5 inches below, 4 inches above for a connection. And we can alter all sorts of things. Again, the seat will be here, so there may be some issues with that, but we want to at least get established a stick geometry and then figure out later from there how we can make things better. Because one thing we want is sufficient travel in both directions. And as we put things together, we can see what type of conflicts we come up to and the number of ways we have to adjust for them. I'm going to show how to make the stick with the offset. This has about a 1.5 inch offset. That's the change in location from this surface to this surface here. And here's our pivot point. So basically we have two curves, one here and one here. And also remember, the stick needs to be double walled or reinforced, at least in the areas where the connections are made. Now if you want to go with a straight stick, you can do that too. You just need to sleeve it with the 7/8 insert and then go ahead and drill the locations. But I'm going to show making the upgraded stick with the offset built in. Here's our 19-inch stick, 1 inch, and I have a 6-inch length of 7/8, which I'm going to slide in as an insert and then mark where the 6-inch stops. So I'll set this all the way till it's flush. And this will reinforce the place where it's going to connect and also the pivot point, which will be just below the 6-inch mark. Now we're going to start our bend at the 5-inch mark. And actually this mark will be for the bender, so 1 inch below. This is where I'll put the bender at, and then do about a 17-degree bend to start the first curve for the stick. So here's the 6-inch mark, and then here's the 5-inch mark. I'm going to put that at my arrow and then bend approximately 17 degrees up. And here's our bend that we put in. The 6-inch mark is where the insert we put in, and this is the 5-inch mark where we place the bender. This is also where the pivot is going to be, because we need 5 inches below the pivot point. So our pivot location will be through the double-walled area. Now we want to measure about 5 inches up, and this is where we're going to make our next bend to bring the stick back so that it is even with this one or parallel with this one. But this gives us the offset of approximately 1 inch. Now obviously if you went further up, you'd get more than 1 inch. The further up you go, the less down or closer you go, the less of an offset you get. So make sure we bend in the same flat plane. I'm going to choose 5 inches from this point to here, and I'm going to put this in my bender, put the mark, the arrow on the bender at this mark, and bend it up. I'm going to bend it up until it is parallel with this one, another approximately 17-degree bend. Now, you can also, or you should also, before you bend, insert another 7/8 inch tube in here, about a 4-incher, so it comes down and rests here, because this will be the location of another connection, and that will stiffen up the wall here. So a 4-inch piece of 7/8 inch tube, slide it down and push it down all the way till it stops at the bend here. And that way this part will be reinforced prior to bending, because once you bend it here, you will not be able to get the reinforcement past the bend. Take note of how we're going to bend this the opposite direction. Here's our mark, and we're going to turn it around. So I continued the mark all the way around the tube, and then the arrow, and we're going to bend it up. And here's the bottom of the stick, our first bend and our second bend. And if we measure the amount of offset, we got 1.5 inches. So we will mount the stick. Its pivot point will be right here. That gives the 5 inches below. The connection with the elevator tube will be 4 inches, which will put it right here. And we'll see how this works out. So at 5 inches up and at the very top of the tube, I'm going to take this over to the drill press and end up with a 1/4 inch hole all the way through, starting small, of course. This will be our pivot point for the stainless steel U-bracket. We'll take it over, see how it looks and fits, and then we have one more hole down here and one more hole up here for the other controls. And here we have installed it with a bolt just to check out its fit and its motion of travel, which looks good. Now we're going to drill a hole down here to connect over to the aileron torque tube, and then we also need a hole up here eventually for the elevator tube, and a side profile to show the offset. 90 degrees from our pivot hole, and at the bottom, no less than a 1/2 inch from the edge, we want to drill a hole. Now this hole will be whatever size your rod end bearing is. This one is a 1/4 inch, so I'm going to make a 1/4 inch hole. If you have one that has a 3/16 hole, then a 3/16 hole. So we want to make it right here, again 90 degrees to our stick pivot hole, and that's where we're going to put in a bolt. And of course this is going to head over to our aileron control rod to push and pull it. There's our hole. We'll put a 1/4 inch AN4 bolt on there, and then here's our rod end, 1/4 inch hole, and then 1/4 28 thread, and that'll fit on here. Put a washer on and a castle nut for temporarily holding it on. And then eventually this will get a threaded rod. We'll have to cut this to length to meet up with the aileron torque tube horn, where we're also going to put another rod end on. Let's go take a look at that. With the stick back mounted and our rod end bearing mounted down here, we can see that we're going to need a piece of threaded rod headed in this direction over to our torque tube horn, where I have also mounted a rod end bearing. I had to drill my hole out to 1/4 inch because my rod end bearing had a 1/4 inch hole. Depends on what size you're using, but it also accepts a 1/4 28 threaded rod in here. So what we need to do is set this horn vertical and set the stick vertical, and then take a measurement between the center and the center over here, and then we'll deduct a little bit because the rod end bearing doesn't thread all the way through, but that way we can get a length for our threaded rod and then connect these 2 points together. Now I tested my rod end bearings by threading the rod in, and they only went in about 3/4 of an inch, about up to here. So that leaves the distance from the center to here to take into account when cutting the length of this rod. So for me, 9.5 inches is what I'm going to cut my rod to get the 11 inches that we're after. But do check this out because your rod ends may be different. Measure everything first before cutting. Measure it twice before cutting. Now, this is where I'm going to cut my threaded rod. I like to put a couple of nuts together, jam them together, and then cut right up even with the nut. And what that does is it keeps your cutting tool kind of straight, hacksaw, Dremel tool, whatever you want to use to cut it. But then also, if you booger up the threads a little bit, which you probably will with the cutting tool, you can roll the nut off the edge, and that helps cleans it up a little bit. And here's our completed rod assembly coming in at 11 inches. And don't forget to always include the jam nut. Now, these jam nuts are important because it's not really for keeping this from turning, though it may certainly do that. But if you ever try without a jam nut and you feel the play that is in there, and that play without the nut over years and years of banging back and forth will wear everything out, make it much looser. If you tighten that up with a wrench, you will notice that it becomes incredibly stiff and solid because it's jamming the rod literally against all of those threads in one direction and holding everything tight as a solid unit. Without that nut, it's all loose, microscopically loose, but you can definitely feel it. And like I say, over repeated operations, that can all fail in there. So jam nut always once you get things in place. Now obviously we can adjust this by turning it in and turning it out, and once we get it the way we want, tighten them up. So let's go put this back on our stick and our aileron control tube and see how it fits. And here we have them attached, and everything is preliminarily installed because we still have to check for clearances and binding when we have the entire system hooked up. So for now, we're just doing piece by piece. But what we want to check now is that we have no binding. We don't really know how far we need to go in all these directions, so we don't want to be too critical on any of the motions yet, because you may go real far one way or real far the other way and find out that the stick will never need to go that far because of the deflections on our elevator. So for now, we just want everything to operate normally and no binding or rubbing, and everything looks good. And of course, the purpose of all of this is that our aileron horn over here is working just nicely. Eventually we'll get that hooked up.
And there you have it. Now, next week, you're going to find out that we're going to be starting the wings, and you'll be pleasantly surprised at how easy it is to put those together. So back to building, and catch you next week.